Hello everybody, welcome to Dr.K.Liu Math channel. This time I will continue my journey of the presentation of conservative vector field. Given that if a vector field of in line integration, a vector field is conservative, which means a path independent. A path independent means whatever we use any kind of path. Of course, the path is a license, and that domain is connected. But we don't discuss the detail in here. We only discuss the technical calculation, that how to calculate that a vector field is conservative. Okay, for in 2D in R2, if a vector is conservative, then we can check whether it's conservative or not. We can check a vector field f, y, m, and n, and check 1 m 1 y equal to 1 n 1 x. But I will use other type of format. Fx can be the vector field can be written as fxi plus fy j. Then partial differentiate with respect to y, and partial differentiate this is x. Then if this is equal, then conservative. I don't want to remember the formula, exactly the formula, because nobody want to remember some crazy things. Unless if you like, you can. But I'm a normal person, so I just try to do the normal things. Partial differentiate the x coordinates with to y, and partial differentiate the y coordinate with respect to x. Then check they are equal. Done. Okay. In this case, then conservative means f(x). F is equal to a function, a gradient vector of a function, of certain function, and this I will show you how to find this function. Okay, here is a question from UST, Hong Kong University of Technology, Science and Technology. I forgot the name. Okay, engineering exam question. F is what determine whether f is conservative or not, and also find the phi x here. And for the question 1, if not, then stop here. Okay, I do the part B because the part B is the easy one. And f x here. Okay, I don't write xy. Ex cosine y I plus ex sine y j. This must be phi x I, phi y j. Therefore, I only check phi x y. Phi x y means differentiate this part with respect to y. Then this is minus ex sine y. Okay, for this one, phi yx, differentiate that's y coordinate with respect to x. That means differentiate this one with respect to x, ex sine x sine y, not equal. Therefore, f is not conservative. Stop here. Okay, for part B, for the A. And here, if it is conservative, then evaluate the line integral by using this formula. If it is conservative, then FB minus FA. FA is the starting starting point of the curve, FB is the end point of the curve. Then here f is equal to 1 plus xy, exyi plus xj. Okay, here phi x equal to 1 plus xy exy. Differentiate this with respect to y. We have 1 plus xy xy. The first part is differentiate this one and plus xy and add them together. This is 2x plus x squared y times e to the power xy. And find y is here, x squared e to the power xy, and differentiate this function with respect to x. Then we also use the product rule, 2x e to the power xy plus x squared times y exy. After factorize the factor e to the power xy, we discover that we observe that actually they are equal. Phi xy equal to phi yx. Therefore, f is conservative. Okay, and next step is how to find this conservative function phi x. Okay, and then we can actually integrate this function with respect to x. Therefore, phi is equal to integrate phi x dx. That means integrate 1 plus xy e to the power xy dx. And here I use integration by part. I write here, let u is 1 plus xy and du equal to y. Because we here is the differentiate the x. Therefore, du equal to y equal to dx. And dv equal to e to the power xy dx. Here integrate e to the power xy with respect to x. Therefore, it is 1 over y e times e to the power xy. And for first part is uv this 2. The second part is minus this 2. This is exy dx. Please don't make any mistake here. Here is dx, not dy. Okay. And then 1 plus xy multiply the delimiter y into the function. This is 1 over y exy plus a function of h y. Please be careful. The constant term is not constant, but related relative to x is constant. Therefore, the constant term should be a function of h. Sometimes we have to adjust this h. We have to pay attention to this one. Okay. Finally, cancel these 2 terms. Okay, the second step is we have to find the hy, and therefore we have to integrate phi y with respect to y also. Therefore, phi can be calculated by using integrate the second part of the vector field with respect to y. This time is y. Again, As this is integrate the function of y only. Therefore, this as x squared and x is constant. Okay, log y x plus a gx. Okay. So far, we have to compare these two files. Calculate the file with different method. They must be the same one. That they have to be same. Therefore, compare these two terms. 1, 2. After compare these two files. We get a conclusion that phi must be equal to x times xy plus a constant. This time is constant. Is constant to x and y. But in many times that if this constant, we don't need to write anything. So this is phi. Okay. Then we go back to the calculation of the line integral. The line integral we along this path. In the interval, time interval 0 to 1. Then when t equal to 0, out 0 equal to 0, 0. This is 0, this is 1. Therefore, the point A should be A, 0.0, A. When t equal to 1, t equal to 1, 1. Sine power 2 is 0. Oh, no. Sine power 2 is 1. Therefore, 2. And when t equal to 1, this is 1. And this is cosine power 2. Cosine power 2 is 0. Therefore, this is 1. This is B. Then, I write here. By the fundamental theorem of line integral, if f is conservative, then the line integral should be equal to phi b minus phi a. This is by the fundamental theorem of line integral. Okay, the phi function is here. X times e to the power xy. And A is this point, 0, 1. B is 2, 1. Therefore, put the point B into the function. This is 2. E times 2 times e to the power 1. 2 times 2 e times e to the power 2. And phi A is equal to 0 times e to the power 0. Then means that final result 2 times e to the power 2. This is the line integration, the over a vector field. Okay, and so complicated. Hope guys can enjoy this video, and if you have any question, or you can comment and this question. Okay, hope guys can enjoy this video. Okay, bye bye.